through projects. In this video, we are going to explain about a project titled Language Independent Data Augmentation for Test Classification. Developing a robust test classification model in a low-resource language confronts the significant challenges primarily stemming from the scarcity of annotated data. The situation is exacerbated by impracticality of amassing the large volume of labeled samples due to the cost constraint. An avenue to tackle this limitation is the generation of synthetic data through the data augmentation technique. However, the majority of the existing augmentation methods are tailored to English data and exhibit the language specificity. As they operate on the granularity of words and the sentences, addressing this gap, we introduced a novel approach known as language independent data augmentation. This innovative technique leverages a multilingual language model to generate the synthetic data transcending the linguistic barriers. Unlike the conventional methods, LiDA operates on the sentence embedding level, rendering it language agnostic and adaptable to diverse linguistic contexts. The proposed LiDA framework holds the promise in enhancing the efficacy of the test classification model and the resource-scarce languages while bypassing the constraint posed by language specificity. This innovative strategy, termed the language independent data augmentation, harnesses the capability of a multilingual language model to generate the synthetic data, enhancing the training dataset for the test classification task. The core objective is to surmount the challenge of acquiring the costly labeled data while leveraging the data augmentation technique, distinguishing itself from the conventional methods that operate at the word or the sentence level within the specific languages and the functions at the sentence embedding level, making it adaptable across the linguistic boundaries. And the evaluation of LiDA spans the three languages involving the diverse portions of the dataset and demonstrate its efficacy in enhancing the performance of the both LSTM and the BERT models. And this groundbreaking technique holds promise in realizing the low-resource test classification task, enabling the more accurate and robust results, addressing the constraint posed by language-specific methods. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the package. This step involves importing the necessary libraries and packages required for implementation of LiDA, data processing, visualization, feature selection, and building the machine learning model. And the second one is exploring the dataset. The dataset is thoroughly examined to understand its structure, content, and the characteristics. Exploratory data analysis techniques are applied to gain the insight into the data distribution and the pattern. And the next step is data processing. Raw data is pre-processed to ensure the consistency and the usability. This includes the tasks like test cleaning, lower casing, and removing the special characters or the stop words. And the next step is visualization using the C1 and the Matplotlib. Visualizations are generated using the Python libraries like C1 and Matplotlib to provide the graphical representation of data distribution, relationship, and the trend. And the next one is data cleaning. Further cleaning steps are undertaken to handle the missing values, anomaly, and the inconsistency in the dataset, ensuring the high quality input for the subsequent stages. And the next step is tokenization based on the BERT for TL and the Keras for the deep learning. Test tokenization is performed using the BERT model for the transfer learning and the Keras for the deep learning model, converting the textual data into the numerical representation suitable for the machine learning. And the next step is feature selection algorithm. Those techniques are applied to identify the most relevant and the informative features that contribute to the classification task, enhancing the model performance and reducing the dimensionality. And the next one is splitting the training and the testing data. The dataset is partitioned into the training and the testing subset, enabling the model training and evaluation on the distant data segment. And the next step is building the model. Here various classification models are built. The first one is CNN over BERT GCN. Convolutional neural network architecture integrated with bidirectional encoder representation from the transformers and the graph convolutional network is utilized, harnessing the power of both the convolutional and the transformer based feature for enhanced test classification. And the second one is LSTM over PERT GCN. Long short-term memory networks are combined with the BERT and GCN to capture the sequential dependency and the contextual information, effectively improving the understanding and the representation of the test data. And the next one is BiLSTM over BERT GCN. Bidirectional LSTM which process the input data and both the forward and the backward direction is integrated with the BERT and the GCN, enabling the model to grasp the contextual nonsense from both the past and the future words. And the next one is LSTM. A standalone LSTM architecture is employed focusing the solely and leveraging the sequential information and the memory cell for effective test classification. And the next one is LSTM plus GRU. The combination of LSTM and GRU layers form a hybrid model that balance the memory and the computational efficiency, aiding in the accurate test classification. And the next one is BERT. The influential BERT model renowned for the contextualized BERT embeddings and the transformer-based architecture is employed for the test classification task. And the next one is GCN with the TorchNet. The graph convolutional network implemented using the TorchNet is utilized to effectively capture the relationship and the dependency within the data, further enhancing the model test classification capability. And the next one is user gives the input. An interface is established using the flags to facilitate the user interaction. Users input test data for the classification through this interface. And the next one is the given input is pre-processed for prediction. Input data from the user is pre-processed including cleaning, tokenization and the numerical conversion, ensuring the compatibility with the trained model. And the next one is that trained model is used for the prediction. The pre-processed input is fed into the trained machine learning model. The models leverage the LiDA enhanced data to make the accurate prediction based on the provided test input. And the last one is final outcome is displayed. The prediction results are displayed to the user through the class interface, indicating the classification outcome based on the chosen model and the LiDA augmented data. And the execution of the project. To execute the project first, we need to open the code folder. And this is the code folder containing of various files within it, the dataset folder containing of the dataset that we use in this project, and the static folder containing of the folders like CSS, JavaScript, images, fonts within it, and the template folder containing of the HTML documents. It typically include home, notebook, results, sign in and sign up pages within it. And the notebook is an IPYNB file which contains the combination of the code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address. Like this, we need to copy this default address and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I am pasting this link and click on enter button. Here it will redirect it to this page containing of the title and some information about it. And then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password, and we need to fill those details and then click on the login button. Here it will redirect it to this index file and where containing of some dialog box where we need to enter the message within it. And I am entering the message, what should have been a painless time killer becomes instead a grating endurance test. And then click on the predict button. Here the result is predicted as of the positive, and by clicking on the home button we can redirect back to this index file and where we can enter the message within it. And here I'm entering the other message to classify it whether it's positive or negative. I'm entering the message as contrived as this may sound, Mr. Rose updating works surprisingly well. And then click on the predict button. Here it will predict it as a result classified as negative. And this way we can classify the test as a positive and negative by using this model. And in conclusion, we introduced LiDA, a data augmentation technique for the test classification, and is not dependent on a particular language and does not require the features of a language. Therefore, it's suitable for the low-resource languages. This experimental result showed that LiDA could improve the performance of the multilingual test classification model without the need of the language adjustments.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.